Alright, here's a quick review of what we learned how to do today. I'm just going to make this equation up, be a matrix equation, and it'll look like so. I have no idea if this will work. Okay, we'll do it like the book has done it, times x equals, and then we'll have our matrix, our constant matrix, and let's make that, I don't know, 16 and 4. Okay, and so this is what we're trying to solve. Again, to kind of review a little bit, this is in the form a times x equals b, and what we want to do is take this equation times the inverse of matrix A on both sides, and what that will do is just end up yielding, this will just be the identity matrix right there, so we'll get x is equal to A inverse B. So in order to solve it by using this method, the first thing we have to do is find A inverse, and A is this matrix right there. So we go through the process of finding the inverse of it, and to do that, the first thing we do is we find the determinant of it, called determinant of A. 2 times negative 1 is negative 2, minus 1 times 3 is 3, so it's negative 5. Then the process for finding the inverse of A we talked about today is found by 1 over your determinant of A, so 1 over negative 5. Then times the matrix, and if you recall, we have to flip-flop the 2 and the 1, so there's a big step, and we have to change the signs on the 3 and the 1 in the upper right-hand corner. And so there's our inverse, but we'll go ahead and multiply out that negative 1/5. And so negative 1 times negative 1/5 is 1/5. And then times the negative 3 is positive 3/5 and negative 2/5. So there is our inverse matrix. Now I'm going to take and multiply both sides of the equation by that inverse. On the left-hand side, I do get the identity times x, which is just going to be x. On the right side is going to be my answer. So I take 1/5 times 16, I get 16/5. Plus 4/5. 1/5 times 4. That's row 1 times column 1. And then row 2 is 3/5 times 16. So that's 48/5 minus 8/5. And so my final answer is 20 over 5, which is 4, and 40 over 5, which is 8. And that is the solution.